So we can never get away from these things where we are now very much focused on annual global greenhouse gas emissions in billions of tons. We have seen this already several times. And the expected warmings with the scenarios that are considered safe and not catastrophic, like 2 degrees C warming compared to with respect to the pre-industrial period by 2100 with let's say a 67% probability, and if we are really fortunate maybe even go down to 1.5 degrees centigrade, which require us to go to negative emissions depending on whether we are just considering carbon dioxide or all of the greenhouse gases. And then we have scenarios where we have no climate policies and we end up with these range of emissions and warmings 4.1 to 4.8 degrees centigrade. And even though we cannot say with great certainty exactly what will happen at local scales, this is not going to be good at all for the glaciers, for sea level rise, for extreme events, for cyclones, crops, health, and many other things. And the current policies that countries have committed to would bring us down to 3.1 to 3.7 degrees C, as we have already seen, and the pledges will further bring us down from that to 2.6 to 3.2 degrees centigrade. Countries are supposed to submit revised nationally determined contributions that they had originally submitted under Paris Agreement, because we are not on track to meet these goals, or not even close. Then there are many economic models which can take these warmings and pathways and convert them to economic outcomes, costs, GDP losses, and so on. So they basically focus on these sorts of things. We are looking at global mean surface temperature for selected climate scenarios, 2031 to 2050 and 2081 to 2100, so earlier decades and long-term warming. Temperature here in the degree C increase relative to pre-industrial levels, so the earlier period would end up with warming under RCP 8.5. It would hit 2 degrees centigrade, and most of them are less than 2 degrees C, but we are crossing 1.5. So there are, you can see that there is a dip here for RCP 6, and there are aerosol scenarios which produce earlier warming that is less than the lower emission scenario of RCP 4.5, and then it takes over later in the decades. So there are issues of how aerosols are behaving in models, so I won't get into those details here. But by the time you reach to the outer decades, you see that that's a monotonic increase from RCP 2.6, which is the benign scenario of remaining below 2 degrees C, even though it'll be above 1.5, and RCP 4.5, RCP 6, and RCP 8.5 again. And the question, of course, is what would it cost to let's say stay on 2.6? There are various numbers thrown out, like 2% of GDP from each country who could do it, but economic calculations tend to remain highly uncertain as well. Nonetheless, economic impacts of climate change are done by many groups in many ways. This is the Economist Intelligence Unit of AFP. Average real GDP loss by 2050, not even 2100, based on the worst case scenario. North America 1.1%, Latin America 3.8%, Western Europe and Eastern Europe there, Middle East, Africa, and Asia Pacific. But one has to also be careful, because if the Middle East gets really hot, as it already is, it shows a pretty strong warming already. And if it begins to have, let's say, fossil fuel either being phased out because of renewables and the climate action, or oil production goes down, then this can obviously be much more than just 3.7%, and other geopolitical issues, religious issues, and God knows what else can all become a mess, right? So these are just, you can take them as estimates that are to be taken with a grain of salt. So estimating climate change impacts, another way it is done by this global giving group, which takes it from somewhere else, but it doesn't matter. I just wanted to give you a sense of how various economic estimates of climate change action and climate change impacts are done. The new articles keep coming out. Just one came out today in Nature Communications saying there are pathways of mitigation which can allow us to maintain high energy lifestyles. But who's leading the high energy lifestyle? All the rich people. Does that account for taking the poor people from the low standards of living to higher standards of living as well? Not always. So one has to be very careful about what those mitigation scenarios actually mean, and who they will benefit and who will pay for it, and what will be the unintended consequences of those things. Let's say geoengineering. So I have course on geoengineering that you can look at various issues there. So dollars are expected to go toward coastal areas due to rising seas and greater storm surges by 2050. So that's the cost of estimated at $1 trillion. People are expected to lack sufficient water by 2050. That's $5 billion. Water and food are definitely some things that one has to worry about, especially water, quantity, quality, and access. Even if there is some great technology that comes about to do large-scale desalination safely, transporting that water and giving access to everybody equitably is not going to be guaranteed to be, accomplished. We will see some ethical issues in the next chapter, and I also have many on climate justice and so on in a course I have called Drawdown and Bending the Curve that you can look up. Okay, people are expected to be displaced by environmental hazards by 2050. So this is, 5 billion people. This is the cost. 1 billion people are expected to be displaced by environmental hazard by 2050. 5 billion people are expected to lack sufficient water by 2050. 100 million people are expected to be pushed into poverty by 2030. 2030 is just around the corner. We are in 2022 almost, December 2021. So before you blink, it's going to be 2030, and the climate impacts are accelerating, so one has to watch out for that. 250,000 additional deaths are expected each year between 2030 and 2050 due to climate change. So how do you value life? And it also depends on who pays the price. If global north continues to benefit, let's say, from global warming, like Siberia becoming very good for agriculture by all the warming and snowmelt, while global south gets too hot to live in, and the agriculture and water become great issues, and health, and then what happens? So all these things have to be considered when we think about economics, future climate impacts, not only on the kind of climate variables, health, agriculture, energy, water that we talked about, but also on the economies of the developing countries. And when we look at the social cost of carbon later on in this chapter, we will see maps of which countries are going to pay a massive price in terms of global warming and its impacts. In terms of social cost of carbon, we'll define what we mean by social cost. I think you have an intuitive sense that it is private cost versus social cost. So what you pay for, let's say, buying electricity or gasoline, and what the impact of that energy use and gasoline use will be on shared resources like the atmosphere, water quality, air quality, and so on. So it's a useful concept, but again, difficulty is of course in how to estimate the social cost of carbon. Essentially, it's the damage done by each additional ton of CO2 that we emit, greenhouse gases. Why additional ton? Because there is a background CO2 level in the atmosphere, and we have been adding to it. So we have to understand the marginal cost of adding another ton of CO2 and its negative impacts on society. So we'll do that in the next podcast. We'll start that in the next podcast. Okay.